In the chemical kinetics lab, you're going to use crystal violet and sodium hydroxide to determine the rate law for the reaction between those two chemicals. So what you're going to do is you are going to mix different volumes and concentrations of crystal violet and sodium hydroxide, and you are going to record the data as those two react and use your data from your LabQuest in order to determine what the rate law is. So first thing, safety-wise, do not pour the crystal violet and sodium hydroxide down the drain. The crystal violet is a biological stain and it's something that cannot go down the drain. So make sure when you're through with those solutions that you pour them into the waste container at the front of the lab. So I will have that set up for you if for some reason you don't see it, ask me about it, but do not pour those solutions down the drain. So let's talk about what you are going to do with your data. So the first thing is you're going to determine what the reaction order is with respect to crystal violet. So our rate law, if you look at your lab handout, we're given a generic rate law. Rate is equal to K times our crystal violet, which we're going to abbreviate as CV, positive because it has a positive charge, raised to some order, which we're going to call M, times the hydroxide, which is raised to some order we're going to call N. So you'll be able to tell the reaction order with respect to crystal violet by looking at your graph. So if a graph of absorbance versus time is linear, then you have a zero order reaction. If a graph of natural log of absorbance versus time is linear, then you have a first order reaction. And if a graph of 1 over absorbance versus time is linear, you have a second order reaction. And since absorbance is directly related to concentration, we can use absorbance in place of concentration. So you have learned in class that concentration versus time, or natural log of concentration versus time, or 1 over concentration versus time. Since Beer's law shows us that absorbance and concentration are directly related, we can substitute absorbance here. So once you look at your reactions, you will be able to tell whether your reaction is 0, first, or second order with respect to the crystal violet. So then once we've determined that, the next thing that we want to know is what is our reaction order with respect to the hydroxide. So the way that you're going to determine that is you're going to use your LabQuest to get the slope, and there are instructions in your lab handout on how to get the slope from your graph. So you're going to take the slope from trial 1 and divide that by the slope from trial 2. And that is equal to your hydroxide concentration in trial 1 divided by your hydroxide concentration in trial 2. And that is raised to the n. So we can substitute our hydroxide concentration in trial 1 is 0.020, but we dilute that 50-50 with our hydroxide, so it's 0.020 divided by 2, which gives us 0.010. So you're going to take your slope from trial 1, divide it by your slope from trial 2, and you're going to plug in your first trial, your concentration of hydroxide is 0.010, and the molarity will cancel out, so we can leave off the units. And then for trial 2, your concentration of hydroxide is 0.010, but we also diluted that in half, so we have 0.005 molar. And we raise that to the power of n. Now the way that we get rid of n is by taking the log of both sides. So we have the log of slope, the slope, not the stoke, trial 1, divided by the slope of trial 2, and that is equal to, so when we take the log of something, the exponent comes out front, oops, I forgot to write the log in there. So n log of 0.010 divided by 0.005, and then we can rearrange this. N is equal to the log of the slope of trial 1 over the slope of trial 2 divided by the log of 0.010 divided by 0.005. So that's how we will get our value for N, which is the reaction order with respect to hydroxide. So then you're going to calculate a value for K. And in order to do that, what you're going to do is you're going to take, if your reaction was 0 or first order, you're going to take the negative of the slope divided by the hydroxide ion concentration raised to the power of n for both trials. And if your reaction order was second order, then you're going to take the positive of the slope divided by the hydroxide ion concentration raised to the n for both trials. And then in question 4, you're going to write out your experimentally determined rate law, where you're going to give what the values for K, M, and N are. So K, M, and N here are going to be replaced with the values that you came up with. So this is what you will need to do for your crystal violet lab experiment once you have all of your data. So make sure you have submitted your purpose and procedure on Canvas before you come to lab, and I will see you in lab.